Right now, you can ask a machine to write a story, create an image, translate a language, or talk to you in seconds. But travel back to 1950. Computers were enormous machines that filled entire rooms. They couldn't hold conversations, they couldn't recognize your face, and they couldn't understand ordinary language. Yet one brilliant mathematician was already thinking far beyond what these machines could do. His name was Alan Turing, and he began his famous 1950 paper with a simple question: can machines think? At a time when computers could do little more than follow basic instructions and calculations, Turing was exploring the possibility that machines might one day show intelligent behavior. It was an idea far ahead of its time, and it would become part of a journey that changed our world forever. Welcome back to TalePath English. If you enjoy stories like this, subscribe to the channel and join us for more fascinating journeys through history. Today, we're traveling back to the early days of computing to discover how artificial intelligence grew from an extraordinary idea into the technology shaping our lives today.
In 1950, Alan Turing published an important paper about machines and intelligence. Instead of trying to explain exactly what it meant for a machine to think, he suggested a simple experiment. Imagine a person communicating with two hidden participants. One is human, the other is a machine. The person asks questions and receives written answers from both. If the person cannot reliably tell which answers come from the machine, Turing suggested that the machine might be showing intelligent behavior. This idea later became famous as the Turing test. At the time, it sounded incredibly ambitious. Computers could not hold natural conversations, recognize faces, or understand everyday language. But Turing was imagining possibilities far beyond the technology of his time. And just 6 years later, a new scientific field would officially receive its name.
In the summer of 1956, a small group of scientists gathered at Dartmouth College in the United States. Among them was a young computer scientist named John McCarthy. The researchers shared an ambitious belief. They thought that abilities such as learning, reasoning, and solving problems could eventually be reproduced by machines. McCarthy gave this new field a name: artificial intelligence. The computers they worked with were nothing like the devices we use today. They were enormous, they were expensive, and their abilities were extremely limited. But the scientists were confident. Some believed that machines with impressive intelligence might arrive much sooner than anyone expected. AI had officially begun its journey, and excitement grew quickly. During the late 1950s and 1960s, researchers began creating programs that could perform tasks once thought possible only for humans. Some programs solved mathematical problems. Others played simple games. And researchers began experimenting with computers that could understand basic human language. One famous program was ELIZA, created in the 1960s. ELIZA could respond to written sentences in a way that sometimes felt like a real conversation. Its abilities were actually very simple. It did not truly understand what people were saying. But something surprising happened. Some users still felt as if the computer understood them. It was an early sign of something that would become much more important decades later. Humans could form a powerful connection with machines through language. The early successes created enormous excitement. Researchers began making bold predictions about the future. Some believed that truly intelligent machines might appear within only a few decades. Governments invested money in AI research. Universities opened new laboratories. Expectations became higher and higher. But there was a problem. The technology simply wasn't ready. Computers were slow and extremely expensive. They had very little memory compared with modern machines. And many AI programs worked well only in carefully controlled situations. When researchers tried to use them for more complicated real-world problems, they often failed. The dream of intelligent machines had moved faster than the technology itself. And soon, the excitement began to disappear. By the 1970s, many people were disappointed. AI had promised extraordinary progress, but many of those promises had not been achieved. Governments and organizations began reducing their financial support. Projects were canceled. Research slowed down. This difficult period became known as an AI winter. The name was appropriate. The excitement surrounding artificial intelligence had suddenly become cold. But AI did not disappear. Inside universities and research laboratories, scientists continued working. They improved old ideas. They developed new ones. And they waited for computers to become more powerful. The dream was still alive. It was simply waiting for another chance. During the 1980s, artificial intelligence began attracting attention again. One important development was the rise of expert systems. These programs were designed to copy the decision-making process of human specialists. For example, a computer could be given thousands of rules about a particular subject. It could then use those rules to help analyze a problem or suggest a possible solution. Businesses became interested. AI was no longer only an experiment inside universities. It was beginning to have practical uses. However, expert systems had serious limitations. Humans had to provide most of their knowledge manually. The machines still could not easily learn by themselves. For AI to make its next great leap, computers needed something different. They needed to learn from data. Then came a moment that captured the world's attention. In 1997, world chess champion Garry Kasparov faced a powerful computer component called Deep Blue. Kasparov was one of the greatest chess players in history. Deep Blue was designed for one specific purpose: to play chess. It used powerful computer hardware to examine enormous numbers of possible moves very quickly. It also used chess knowledge and strategies prepared with the help of human experts. This was very different from the machine learning systems that would become important later. Millions of people followed the competition. And then something historic happened. Deep Blue defeated Kasparov in their 6-game match. For many people, the result was shocking. A computer had defeated a world champion in one of humanity's most famous games of strategy. But Deep Blue was not thinking or learning like a human. It was a highly specialized machine using enormous computing power and carefully designed chess knowledge to perform one particular task. Still, the match sent a powerful message. Computers were becoming capable of doing things that once seemed impossible. And behind the scenes, researchers were developing a very different idea: machines that could learn from data. Behind the famous chess match, another important change was happening. Researchers were developing better forms of machine learning. Traditional computer programs usually followed instructions written by humans. Machine learning offered a different approach. Instead of giving a computer a rule for every possible situation, researchers could give it large amounts of data. The computer could then search for patterns. Imagine showing a computer thousands of pictures of cats and dogs. Over time, it can learn patterns that help it tell the difference between them. This idea would become extremely powerful. But researchers still needed two important things: much more data and much more computing power. Soon, they would have both. By the early 2010s, the world had changed. The internet had created enormous amounts of data. Computers had become much faster, and researchers had improved a technology inspired loosely by networks of neurons in the human brain. These systems were called neural networks. In 2012, a neural network called AlexNet achieved remarkable results in a major image recognition competition. It could identify objects in photographs far more accurately than many earlier systems. The result attracted enormous attention. Researchers and technology companies began investing heavily in deep learning. Soon, AI became much better at recognizing images, understanding speech, translating languages, and finding patterns in enormous amounts of information. After decades of slow progress and disappointment, AI was accelerating. Then, in 2017, another major breakthrough arrived. Researchers introduced a new type of AI architecture called the transformer. Its ability to work with language would become especially important. Transformers could examine relationships between words and understand how different parts of a sentence were connected. With enough training data and computing power, these systems became increasingly good at predicting and generating language. This helped researchers build much larger and more capable language models. They could summarize information, translate languages, answer questions, and generate sentences that sounded surprisingly natural. The pieces were now coming together. AI had spent decades learning how to calculate, recognize patterns, and process information. Now, it was becoming much better at something deeply human: language. As these systems became larger and more powerful, something remarkable began to happen. AI was no longer only recognizing information, it could generate new content. It could produce sentences, create images, write computer code, compose music, and answer questions in natural language. This became known as generative AI. These systems learned from enormous collections of existing information and used patterns in that training to produce new outputs. For decades, people had imagined intelligent machines in books and movies. Now, millions of people were about to interact with powerful AI systems themselves, and one product would bring this technology directly into homes, schools, and workplaces around the world. On November 30th, 2022, OpenAI released ChatGPT to the public. The idea was simple. People could type a message, and the AI would respond. But what happened next was extraordinary. People asked it to explain difficult ideas. They used it to write and summarize text. Students used it to study. Programmers asked it for help with code. Others experimented with stories, languages, business ideas, and everyday questions. For many people, this was their first direct experience with powerful generative AI. Artificial intelligence was no longer something that existed only inside research laboratories or technology companies. It was suddenly available to ordinary people, and the world began paying attention. Since then, artificial intelligence has developed at remarkable speed. Today, AI can help people translate languages, analyze information, create images, write software, study new subjects, and communicate across language barriers. Doctors and scientists are exploring ways to use AI in research and medicine. Teachers and students are discovering new ways to learn.
Businesses are using AI to complete tasks that once required many hours of work. But this progress has also created difficult questions. What happens when AI makes a mistake? How can we protect people's privacy? How do we know whether an image, video, or piece of information is real? And how will AI change the jobs people do? The technology is becoming more powerful, but humans still have to decide how it should be used.
The story of artificial intelligence began with enormous machines, handwritten calculations, and a small group of scientists who believed computers might someday become more intelligent. For decades, progress was slow. There were exciting discoveries. There were failures. There were years when many people stopped believing in AI completely. But researchers continued. And today, ideas that once belonged to science fiction have become part of everyday life. Alan Turing could never have known exactly what artificial intelligence would become. But the question he explored more than 70 years ago helped open the door to an entirely new world. And perhaps the most important part of this story is that it has no ending yet. AI is still developing. Its future will not be decided by machines alone. It will also be shaped by the choices humans make about how to create it, control it, and use it. The story of artificial intelligence is still being written, and all of us are now living inside its next chapter.
It's time for questions. Write your answers in the comments. Artificial intelligence has changed enormously in only a few decades. How do you think AI will change our lives in the next 10 years? And do you think artificial intelligence will bring more opportunities or more challenges? Share your thoughts in the comments. Thank you for joining us on this journey through the story of artificial intelligence. See you in the next story.